Okay, good morning, everyone. We can go ahead and get started with ethical machine learning. This is always a topic that causes healthy debate, so we'll see where we land this morning. By show of hands, how many of you have watched too many Hollywood movies and are afraid of AI and ML? Nobody? No one's afraid of AI and ML. How many people have had an opportunity to at least play around with machine learning? How many people use machine learning on their day-to-day jobs? You are very lucky. I have been in tech for a very long time, and I can tell you machine learning is just so much fun. So now, you can either raise your hands, or you can just think in your head, are these situations I'm about to share with you ethical or not? A man is not granted parole because a machine learning model says he will be a repeat offender. Ethical or not? A woman's life is saved because a machine learning model found cancer undetectable by a doctor. Now, this one should really hit home for those of you from the UK. More than 1/3 of A-level results in the UK downgraded by a machine learning model. And lastly, women aren't recruited by Amazon because a machine learning model incorrectly learned that women don't make good engineers. As machine learning moves from the research lab to the large enterprise, questions around ethics and risk become even more critical. And by the way, all of these examples that I shared with you actually happened in real life. There's a system used in the United States, where I'm from, called Compass. And judges and courthouses use it to determine if someone will be a repeat offender. Well, this system caused major uproar because it was biased against people of color. And there are machine learning models in use today that can actually detect breast cancer that a doctor can't see. And A-level results were downgraded, and in my research, I saw that a lot of people in the UK did not like it. And then I'm sure you've heard about Amazon's recruiting tool that was biased against women. Caused a huge uproar, and it had to be scrapped. After our time today, you'll understand more about ethics and how to incorporate it in your machine learning process. Hi, I'm Kesha Williams. I love telling my journey not through the organizations where I've worked or the titles I've held, but through the technologies and programming languages that I've learned. But before I do that, who's heard of ChatGPT? I'm sure everyone in this room. And so I could not resist asking ChatGPT about me. And the response that I received back through prompting was very spot on. So ChatGPT says, Kesha Williams, it's likely that this person is a professional in the IT industry with a focus on machine learning and the AWS platform. They may also be active in the developer community and enjoy mentoring others in the field. Well, that is spot on about me. I'm in IT. I love machine learning and AWS, but I love even more just sharing my love of machine learning. So we'll see who can beat me. So I've been in tech for 26 years. My very first programming language was the BASIC programming language. Who's heard of BASIC? Okay, can anybody beat BASIC? Assembler? Anybody? Nobody? BASIC wins. Then, after learning BASIC, my first job out of college, I used what I call the precursor to .NET. So active server pages, ActiveX control, and VBScript. After that, I learned Java. I literally remember the day that Java came out. I researched the language, and I thought to myself, wow, this language is going to take over the world. This is where I need to take my career. And that's what I did. And I think it was the best decision that I've made so far because Java gave me a solid foundation. After Java, I learned about the cloud and AWS, Amazon Web Services. And when I learned about the cloud, that same excitement that I felt for Java way back then, I felt it for the cloud. After the cloud, I learned artificial intelligence and machine learning. And I can say that if it weren't for AWS, I would have never gotten started with machine learning. I always thought you needed to be working in a research lab, have an advanced mathematics degree, going after your PhD to even use or understand machine learning in the real world, and that's just not the case. Next, there's a question mark. I'm still trying to figure out what's next for me. I think about my journey from Java to the cloud to machine learning. What's next? If anyone has any great ideas, please let me know. So that's a little bit about me. I currently work for a company called Slalom. We are a consulting firm helping organizations migrate to the cloud, of course, and build cloud-native applications. Now, contrary to popular belief, I do not work for AWS, but I am an AWS machine learning hero, ambassador, and Alexa champion. So I just love being active in the community, giving back, and sharing my lessons learned. And so that's the recognition from AWS. So what is AI? Before we talk about ethical AI and the risk there, it's important for you to understand what AI is and how the process works to build a machine learning system. Well, AI is very simple. It is just the simulation of human intelligence by machines. And with machine learning, it's basically a subset of AI that applies mathematics to large data sets to find trends and patterns to make recommendations. So that all simulates intelligence. Machine learning is very widespread. When I first started researching it, I was blown away about how pervasive the technology was and how it already touched my life. Who in here has Netflix? A lot of people have Netflix. Well, Netflix uses machine learning to recommend movies, and Amazon uses it to recommend products. It's also used for risk assessment. I was literally shocked when I learned that judges actually use machine learning to determine if someone is going to be a repeat offender. And that could impact their length of stay in jail and whether or not they receive parole. Banks also use it to determine if you're going to default on the loan that you're applying for. That's risk assessment. And then audience segmentation. Machine learning is used by, at least in the US, a lot of department stores and fast food restaurant chains like Starbucks. They use it to better understand their customers so that they can market better, make customers more loyal, and improve their market share. Anomaly detection. Credit card companies use it to see if your most recent transaction is fraudulent. And it's also used to detect suspicious user activity when you're logging into a system. Personalization, learning customer behavior, and tailoring the experience of a product. Who's heard of Noom? It's the weight loss system. So of course, for my New Year's resolution, I decided, hey, let's lose some weight in the new year. And so I signed up, I entered all of my information in Noom, and they actually use AI and machine learning to tailor the program to me. Now, of course, I haven't started it yet, but I plan to as soon as I get back home. And then facial recognition. This is where you identify people and objects and images and videos. I was shocked to learn that Delta Airlines actually lets you board a plane using your face. You no longer need a boarding pass. And of course, government agencies across the world use facial recognition to identify people. And of course, chatbots. You all have heard about ChatGPT, which is a chatbot on steroids. For example, when you reach out to online customer support, like I did the other day for my Delta Airlines ticket, I was at first speaking to a chatbot. So machine learning is widespread. So how do machine learning systems work? It's very important to have this solid understanding of the life cycle so that you can see where bias and ethical decisions need to happen. So first, with machine learning, the machine studies data, so it's all about big data. And when I talk about machine learning, I always tell people right now in the IT industry, we have this perfect storm. So machine learning and the learning algorithms have been around since the 1950s. But why now, all of a sudden, there is just this huge buzz around machine learning? Well, we have this perfect storm. We have big data, and you need a lot of data to train an accurate machine learning model. So we have big data. We have cloud providers like AWS that make the technology more accessible, really accessible to everyday developers. Like I mentioned, I would have never gotten started if it hadn't been for AWS. And also, you have high-powered GPUs that you need to train models available through the cloud at the click of a button. So that's why now every organization is trying to leverage machine learning. So machines study data, and they find trends and patterns in inputs over here on the left and outputs over here on the right. And the machine learns how to map the inputs to the outputs. Sounds really simple. The mappings found are stored in a mathematical model. So you hear data scientists talking about the model. That's what they're referring to, the collection of trends and patterns. And then, once you have this model, it is sent input and output that it hasn't seen before, and it uses the trends and patterns it finds to make a prediction. So will this person be a repeat offender? Yes or no? What should this person's final grade be? And what is this an image of? How many traditional software developers do I have in the room? Almost everyone. This is NDC, right? So let's compare the traditional software development lifecycle to the machine learning lifecycle. So just like there's the SDLC, there is a machine learning lifecycle. Now, in traditional software development, we write the code to tell the machine what to do. And the software spits out the data we need. We use languages like Java, which of course is my favorite language, C#, JavaScript, Node.js, and Python. But with machine learning, we sort of reverse and flip that process. In machine learning, we give the machine the data, it writes its own code, and then it helps us solve the problem we're trying to solve. Now that is very cool. So unlike traditional software development, machine learning allows the computer to produce output without us programming it. The machine learning lifecycle is very similar to the systems development lifecycle, but first we start with training data. And in this example, we're using home prices and the factors that influence that to teach the machine how to learn to predict the cost of a home. So you have the data, you send it through what's called this training process. So you'll feed the data to a machine learning algorithm. It then learns and it produces this model. And now this model is still a piece of software, garbage in, garbage out. But once you have this model, you can then put it in a production system, integrate it into your existing applications, and you send in input. So in this case, the input that you're sending in, the factors that could influence the cost of a home, like age, location, ocean proximity, number of bedrooms, etc. You feed that to the model, and then the model spits out the price of a home, and it's called a prediction. And so ethics and risk can arise at any point in this machine learning lifecycle. When you have this output, you think to yourself as a developer, can I trust this? Can I find errors? Why is the prediction so expensive? Those are all ethics questions. So of course, I continue to have fun with ChatGPT, and I asked ChatGPT, what is ethical AI? Now this could be considered a conflict of interest because I'm asking AI about AI. But when I got my response back, it was spot on. You see terms like fairness, transparency, responsibility, human rights. Don't perpetuate bias. Consider potential consequences. Mitigate the negative impacts. And these are all great key terms for ethical AI. Now, when I think about this definition, an ethical AI, it boils down to a very simple question. I can build it, but should I? And if I do, what guardrails are in place to protect the people? So it just boils down to this question. And I can be honest with you, building a production-ready machine learning system that you actually trust with the lives of people is very difficult. You have to just be deeply skilled at understanding bias, understanding sophisticated machine learning algorithms and models. And it makes it even harder when you add ethics and risk into the equation. I've been working with machine learning since 2017. I made that transition from Java to the cloud on AWS, and I still feel like I've only scratched the surface. I've developed models to predict crime in the UK. I've developed models and deployed them to edge devices to alert me when my daughter gets home and to tell me whether or not she's happy or sad. I can tell you, having a teenage daughter, they can be very moody for no reason at all. So I like to know if she's happy or sad. And if she's sad, I'll stop by my favorite restaurant and bring her her favorite flavor of milkshake. I've developed models to detect whether or not my kids are stealing soda from the refrigerator when I go to sleep. I have 3 kids, 2 boys and my daughter that I just mentioned, and they love snacking. And sodas just tend to disappear. And so I have a system that alerts me when they go into the refrigerator. I've developed models to make course recommendations on the A Cloud Guru platform. And in the early days of COVID, I developed a model to predict COVID outcomes. Will the person live or die? Again, a lot of fun use cases, but just because I can build it, should I? And how can I trust it with the lives of people? So I mentioned the word bias. I'm sure all of you working with machine learning, you've heard that term before. It's a huge problem, and it goes against the code of ethics. A machine learning system is considered to be biased if it favors or disfavors certain groups of individuals when there is really no major difference between the individuals that cause that output, prediction, or recommendation. We make recommendations or predictions about people. We can determine their identities. That's the facial recognition used by the government, by police forces. We make predictions about their demographic attributes, their preferences, will they like this movie or not, and also about their likely future behaviors. Will they be a repeat offender? We need those recommendations to be fair, and it's very important to mitigate bias at every stage of the machine learning lifecycle. Because of bias, San Francisco was the first major US city to ban the use of facial recognition by government agencies. And when I saw this headline, I was very sad, because as a technologist, the technology is not the problem. It's how we, the humans, have implemented the problem. More specifically, in the case of facial recognition, the issue is the data set that we've used to teach the model does not accurately represent the environment that we intend to deploy the model. And so I personally was highly offended by banning technology. So to just really bring home the example of bias and how it can present itself, let's look at a very simple example. Let's say we are training a machine learning model. We're going to use image classification. We're teaching it how to identify flowers in an image. And let's say this is our training data. Does anyone see any issues with this data? Jump right in. What issues do you see? Yeah. Yeah, there are a lot of issues with this training data. A lot of issues. So we're teaching it to identify flowers in an image. When we look at this training data, first, we're telling the machine, this is what the machine is going to learn, there are only 2 types of flowers in the whole world. That's not the case. Also, we're teaching the machine that most flowers out there are sunflowers. So you should favor sunflowers. Not good. So let's say we have our model and we feed the model a picture of a sunflower. What do you think it's going to identify? It's not a trick question. A sunflower. What if I pass in a rose? Well, maybe it may identify that it's a rose. More than likely, it's going to just say, hey, it's a sunflower. Now, what if I pass in a tulip? It just explodes, and the server shuts down, and that's it. Now, who knows what's going to happen? We have to make sure that we test this before we release it to production, so we know what happens. Now, instead of looking at it using images of flowers, and in this case, we've trained the model to hate tulips. What happens when we are building a recruiting tool? We want to automate our recruiting process, help us find the best software engineers. And this is the data that we train the model on. When you look at it from this angle, Who do you think the model hates? And so this is exactly what happened with the Amazon recruiting tool that I mentioned to you before. They were building a tool to help them recruit software engineers. And when they trained the model, their data set was reflective of the people that had applied before. And mostly men had applied. And so the model learned that, hey, we do not want to recruit women. They don't make good software engineers. And so anytime a resume from a woman came in, if it indicated, hey, I'm a part of women in tech or women who code, or I went to an all-female college, that resume was automatically kicked out. And so here again, the technology is not the problem. It's how we've implemented the system, how we've developed the system. In the pre-machine learning world, humans made hiring, advertising, lending, criminal sentencing decisions, and more. And these decisions in the US are governed by federal, state, and local laws. And they look at the decisions made in terms of fairness, transparency, and equity. It is actually against the law to discriminate against anyone because of their age, their gender, their marital status, being pregnant or on maternity leave, they have a disability, their race, their ethnic background, their religious beliefs, or their sex. But now, machines make or heavily influence these decisions, and guess what? In the US, IP laws actually protect the inputs to this algorithmic decision-making process. It's considered a trade secret. So that means companies in the US don't have to share this information. And the way I look at it, discrimination wasn't allowed before machine learning, and it shouldn't be overlooked now because we're using machine learning. We're all well aware of the outcome of biased decisions. There's a tendency to unfairly allocate opportunities, resources, and information. You infringe on the civil liberties of human beings. You could even pose a detriment to the safety of individuals. There have been cases where facial recognition has incorrectly identified people, having them arrested, spending time in jail, and that should not be the case. You can fail to provide the same quality of services to some people as others. Going back to the home loan or the auto loan, if a machine learning model, for whatever reason, deems that you will default on that loan, then you're likely to not get that loan. But is that actually a fair decision? You can negatively impact someone's well-being, their mental health, by being derogatory or highly offensive. And then, this should happen more than it does, but employees of large organizations building machine learning systems that directly impact the lives of people should raise their hand and cause internal conflict if they're being asked to build something that is going to make the world a worse place. Bias shows up throughout that machine learning life cycle that I talked to you about. First, it can show up in your people, and we'll talk more about this. It can show up in your strategy, of course, in your data. That's one that people are very familiar with. It could also show up in your algorithm, in your model, and in the action that you take based on what the system recommends. So how does bias show up in your people? What do people do? Well, we build the machine learning systems, and we have certain perspectives about life, about what's right and what's wrong. questions that you need to think about with your people and the teams that you have in place building machine learning systems. One, is the team diverse enough to represent minority viewpoints? When we go back to the facial recognition example, the data set was biased. So the data that the software engineers used to train the facial recognition did not represent the environment that that model was going to be deployed in. So that team was not diverse enough to even think that we need more diverse data to train this model. And two, that team did not accurately, fully, thoroughly test the system before it was deployed on the larger population. And then, is this person biased? And could that bias transfer to the system? All of these are questions that need to be asked. And it goes back to my statement, just because I can build it, should I? It can show up in your strategy. So during the strategy phase, you're exploring your existing business processes, trying to identify where machine learning adds value, and then you're starting to define the inputs and outputs. A lot of organizations, because there's such a buzz around AI and machine learning, they just want to try it out. And they will incorporate it anywhere they think it adds value. But from a strategy perspective, if you can actually solve the problem without machine learning, then there's not a reason to use machine learning. During the strategy phase, there are several questions that you can ask yourself. One, how could this system negatively impact people? Could this system deem a potential repeat offender as a low risk? What prediction error rate can you accept? No machine learning model performs at 100% accuracy. I wish that were the case. There will be errors, false positives, false negatives. You need to decide upfront what you're willing to accept and what you require from an accuracy perspective. And then, will you need to explain how the inputs influenced the outputs? I'm sure a lot of you have heard, really when it comes to machine learning, there is a black box around that process in the middle between the input and the output. What if someone calls in for an auto loan and they're denied and they ask, why? Well, you can't say the machine learning model said no. That's just not going to fly. You need to be able to reasonably explain why the answer is no. And this is a common one. This is the one that most people are familiar with. Bias shows up in your data. Typically, in that machine learning lifecycle, you're formatting your data, you're processing it, and you're preparing it for the machine learning lifecycle. And honestly, that takes the most time, and it is the most important part. You analyze and understand the data so that you can find anomalies, because anomalies can impact the accuracy of the systems that you're creating. And then you oftentimes pair your engineers with the subject matter experts. So when I built the machine learning model to predict crime in the UK, I wasn't an expert in crime data. And so I spent hours and hours just visualizing the data, using visualization tools, understanding the data, trying to learn from the data so that I could pull out any anomalies and outliers that would impact performance. And during that process, I did this in 2017, I definitely learned how crime flows in the UK. And I remember at that time, I had never visited London before. This is now my 7th trip. I had never visited London before, and I told myself, if I ever go to London, one, I'm never going during this month because there's just so much crime, and I'm not going to this location because there's just a lot of crime there. And so it's very important when you're building machine learning systems to understand and know the data. And so risk and ethics questions. Will protected attributes like gender, age, or ethnic background influence the output? And also, when I trained the crime predicting model, it had in there location, gender, age, race, and it was very interesting the trends that I saw across those protected attributes where you're not allowed to discriminate on those things. And then also are seemingly harmless features like salary hiding proxies for protected attributes. And so what we see, and this is just how it is, there's a strong correlation between income and race. And so just naively doing income filtering, you're going to discriminate on race. So looking for those things in your data is very important. And then how will you enable users to control the use of the data you have on them? And we'll look at the GDPR and some of the legislative requirements in the US around data ownership, because that impacts that question. And then bias can show up in your algorithm. And this is the algorithm selection phase. So remember, in that process, you have your data, you feed it to a machine learning algorithm. There are tons of machine learning algorithms to choose from. And you really have to choose the best one for the problem you're trying to solve. And so you can experiment with the various algorithms to see how they perform on your data. I taught a 2-day workshop, machine learning workshop here, Monday and Tuesday, and we tried different learning algorithms, and we saw just out of the box, XGBoost, which is a learning algorithm, performed better with no tuning or tweaking out of the box on predicting the cost of homes in California. You also test the model performance on a reserved test data set to verify functionality before you release it to the wild. In that 2-day workshop, we reserved 20% of our data to validate the model's prediction power. And then risk and ethics questions. Which metric will you use to evaluate your model's performance? It's important to measure accuracy, and there are many metrics that you can use, and you need to decide on the best one. And lastly, does your use case require a more interpretable or configurable algorithm? Some algorithms allow you to fine-tune the parameters, called hyperparameters, that you pass, and others don't. So if that's a need that you have, that goes into your algorithm selection. And then model retraining. Models have a tendency to drift during the retraining process as new data comes in. So it's very important to be mindful of that. And in this process, you integrate your model output to your business process, you monitor your system for failure, and you measure and report results. And then the risk and ethics questions you ask. Do you have a plan to monitor poor performing models? How do you handle that? Do you have a plan to store model predictions in case a customer requests that information? And can a bad actor actually look at your data, look at your output, and infer information about individuals? Lastly, bias shows up in your action. So this is what you do once you get the output or recommendation or prediction from that model. How do you interpret the results and output? How do you take action? Does a human review the output for fairness and accuracy? How does the human provide feedback? So let's say the human reviews the output and looks at the input and can't understand why the system said no. can explain why they said no? How do they give feedback on what they're seeing? And how does the human understand the output and recommendations? So these are all ethical AI questions around risk and ethics that you can ask at each phase of the machine learning lifecycle. And when we think about mitigating bias, there are a couple of things that we can do. Going back to that flower example, ensure your data set represents the environment the model is going to be used in. In the world, there are more than 2 flowers. Determine if there are disallowed biases. So we talked about the strong correlation between income and race and how you'll need to untangle that before you train a machine learning model. Because based on the laws in the US at least, you can discriminate on income, but you can't discriminate on race or ethnic background. And so yeah, that's the one related to the correlations and just untangling that. And then determine the impact and decide if you're going to mitigate or allow it. How many of you have heard of explainable AI? That's gaining in popularity, and it's a very important part of ethical AI, and there are several components. But it really boils down to being able to explain why your model functions the way that it does. Having that black box process is no longer acceptable. So look at explainable data. What data was used to train the model and why? Look at explainable predictions. How important were particular features and their weights during the training process? And then lastly, explainable algorithms. What are the thresholds used for a prediction? Let's say a model has an accuracy score of 60%, hopefully that's not in production, and it returns a 75% confidence that the person will pay the loan back. Is that enough for you to grant that loan? Maybe it should be 95%, which is almost perfect. And I don't think anyone's perfect, so you have to figure that out. And when we look at incorporating ethics and risk and explainable AI, you can bake in those checks and balances during each life cycle phase. When we look at the strategy and the problem formation, just stop and think, like I said before, is machine learning an ethical solution to this problem? When we look at the data set creation and construction, does the data need to be modified to mitigate bias? And when you're dealing with protected attributes like gender, race, the answer is typically yes. And then algorithm selection. Can hyperparameters be tuned for accuracy and fairness? So you'll spend a lot of your time in this process trying to improve the accuracy of your model before you release it to the wild. Then you have your training process. And then the most important piece is your testing process. Has the model been evaluated using relevant fairness metrics? Has it been tested on the set that it's going to be deployed on? And unfortunately, a lot of times, the answer is no, leading to technologies being banned. And then deployment. Is the model deployed on a population that it was trained and evaluated for? And then, like I mentioned before, monitoring and feedback. Does the model allow for feedback loops? Now, what I've described to you, the process is very manual. Wouldn't it be nice if there were an automated way to do this? Well, if you use AWS, the answer is yes. And again, I want to say I do not work for AWS, so I'm not here trying to sell you anything. I'm just a technologist that loves tools and technologies. And in 2020 or 2021, Amazon released SageMaker Clarify. Now, if you're new to AWS, there's a tool called SageMaker, and it is an end-to-end machine learning service that allows you to execute the entire machine learning lifecycle in one system. And so they added this new tool called Clarify that can test your models for bias. It also opens up explainable AI, and it helps you explain why your model behaves the way that it does. It produces bias and explainability reports. So it's definitely something you should play around with. So when we look at this machine learning process, SageMaker Clarify integrates at 3 points. First, Clarify can be integrated into your data set construction phase. There's a tool called SageMaker Data Wrangler that does exactly what it's named for. It helps you wrangle your data, transform, encode, clean your data, visualize your data. But at this point, before you even train your model, you can use Clarify to identify bias so that you can tackle that head on. You can also use Clarify during training and testing. You can create a processing job to detect bias and explain your model predictions. And then lastly, when your model is already deployed to production, you can use Clarify to monitor that model for bias drift in production. Very cool. I will say that Clarify is still in the early stages. AWS often releases products and they just continue to change, enhance, and expand. But I did have an opportunity to play around with SageMaker Clarify in a Jupyter notebook. So you're able to use Python to run the bias report. You specify your input features. So for example, for the crime prediction model, you can enter gender or age as particular fields that you want clarified to evaluate for potential bias. And so it runs an analysis job on those features. It provides you with a visual report, a description of the metrics, and measurements of bias. It also looks at the balance of your data set to ensure that it's not imbalanced. Next, each bias metric has detailed examples that you can explore. The class imbalance that I just mentioned can look at the positive proportions and a whole host of other metrics. You can also summarize the results in a table to make it easier to read, and the reports are also available as downloadable PDFs or HTML files from an S3 bucket. And then you can, along with the bias report, pull an explainability report, and it explains why your model did what it did. So you can understand which features contribute to the model prediction, you can monitor it for changes in behavior, and you can explain your predictions in real time. It's very cool. Check it out. And as we wrap up our talk, you may say, Kesha, ethical machine learning is nice, it's important, but so what? Sometimes I care about doing what's right, sometimes I don't. Well, as a developer, you could be putting your company in the hot seat when it comes to machine learning. With GDPR, it requires you to tell individuals about the information you have on them, and if you're going to use artificial intelligence to process someone's data, you need to tell them about it. It covers data ownership, the right to forget, so individuals can actually demand that you erase all of their data from your servers. It includes the right to explain data, and it also talks about AI and innovation. And it specifically says AI cannot be the sole decision maker in choices that have legal or other significant effects on users. Very important and very much needed. On the flip side of that, in the US, we have an AI Bill of Rights that was just released in October of 2022. So before that, it was just the wild, wild west. Now, the blueprint for AI Bill of Rights covers a lot of what the GDPR covers. So safe and effective systems, we should feel protected from AI. Algorithmic discrimination protections, we should not face discrimination from algorithms, and systems should be designed in an equitable way. Data privacy, we should be protected from abusive practices. Notice and explanation, we should know that an automated system is being used, and we should understand how it contributes to the outcomes. And then lastly, human alternatives and fallback. So this is basically saying a human needs to evaluate the output and determine if it's fair or not. All things that just make common sense that weren't being done before. So duty as engineers, and really my call to action to you. When you're building machine learning systems, please don't make the world a worse place. Look at it from a moral and ethical standpoint and use your software engineering powers the right way. Thank you. I think we have time for a few questions related to ethical AI. Any questions, any thoughts, any concerns about how we're using machine learning in the world today? Yes, all the way in the back.
Yeah, I was just wondering, on the basis that you're saying there's new legislation in America and the UK on how AI should be used and things, how practical is that to implement when potentially the inputs are regarded as company property and that may not be as transparent as maybe you'd like it to be to really make sure that bias is taken away from the
Right, so the question is related to how practical are the law enforcement pieces that we have in place, GDPR, AI Bill of Rights. How practical is it to enforce that, given that the inputs are protected, at least in the United States, by IP laws? And that is a great question. So with the AI Bill of Rights, right now it's more of a guide. Okay, it's not like official law where if you break the law, then hey, your company is fined, you're arrested. So right now, there isn't really a way, at least in the US, to enforce it. I do think, though, at some point in the future, this is just the first step, and in the future that there will be heavy fines and bad press and things like that. But again, like you said, the inputs right now in the US are protected by IP laws. It's more around the output, judging the output. Are you fairly giving home loans to, I'm making this up, all different types of people? So we can at least judge the output and look at the trends of how a company is behaving. So, great question. Any other questions? Okay. Well, thank you for your time. I'll hang around up here for a little while in case someone else has any questions. Thank you.